How does AIOps relate to DevOps? AIOps is definitely supportive of DevOps. DevOps, as you know, the goal is to increase the delivery speed and effectiveness and lead times, frequency of releases, at the same time improve reliability and quality. But so AIOps can work closely together with DevOps to improve each other. There are 4 items identified in the chart here. First of all, AIOps can enable continuous deployment, CI/CD, or people just call it continuous deployment, CD. So it reduces the effort of identifying and troubleshooting problems in production, therefore increasing confidence that deliveries are going to be good quality and not have to be reverted. The second column here is AIOps improves collaboration. So collaboration between dev and ops, for example. It extracts and shares relevant insights across complex system architectures so all teams can participate in delivering value to users. The third column here is about AIOps leveraging automation. It's one of the key maxims or principles of DevOps culture geared towards enabling automated remediation of known issues, also automation of deployments supported with good feedback. The second way of DevOps, for example. And the last pillar here is has to do with development lifecycle. So AIOps can actually help accelerate the development lifecycle by taking advantage of data produced during development as well as during CI/CD, exposing what it finds to developers early in the software development lifecycle. Well, there's at least 4 ways that AIOps can help DevOps. How do you view DevOps, AIOps as in silos, or how can they help with different silos? One of the key ideas of DevOps is to reduce the silo between dev and ops, for example, and to make it easier for development to deliver to operations smoothly. With the integration of human AI teams, so human and AI, AIOps can extend DevOps collaboration, enabling communication, shared accountability between human operators and machine learning agents, softening the boundaries between the different roles and improving the overall velocity just because of collaboration. Generally speaking, feedback loop enhancement. So this is, again, like the second way of DevOps, is feedback with machine learning agents in the loop. Teams can iteratively refine systems faster, use AI-generated insights alongside of human judgment, continuously optimize service delivery pipelines. The third approach identified here is accelerating value streams by integrating AI into the continuous improvement cycle. AIOps can empower proactive system operations and automated incident response, enabling smoother delivery of customer value with fewer handoffs. And collaboration reimagined, kind of the same as the first point to some extent, but where DevOps focuses on human-to-human team collaboration, AIOps can bring a machine learning, aspect to capabilities to co-participate in workflows, shifting from humans to tools, and the humans and AI agents for smarter outcomes. Here's a case story. It's actually come from a blog, Itria, via AIOps, breaking operational silos with AI-powered collaboration. According to a recent blog, the deployment of AIOps significantly improved cross-functional collaboration and operational efficiency by unifying operations teams traditionally divided by technology domains under a single data-driven platform. Integrating generative AI-powered insights into existing chat applications, enabling teams to receive real-time analysis, such as incident triage, root cause suggestions, and remediation steps within their workflows. This removes friction and it encourages shared situation awareness. By automating root cause analysis, incident triage, and remediation suggestions, teams were able to work together more seamlessly, reducing manual handoffs and minimizing human error. So the result of that was faster resolution times, stronger alignment across previously disconnected teams, and increased focus on strategic work rather than firefighting. Lots of good benefits there. All right, let's now turn to AIOps in relation to site reliability engineering. So site reliability engineering, as you know, is all about applying engineering practices to the operation side of the house, if you like. It offers a fresh perspective for understanding performance and user experiences that systems deliver. It goes beyond the basic, focus on availability, which is a portion of the time a resource is ready to perform requested actions, and into the more intricate concepts of maintainability, how to quickly and easily, can something be fixed, then reliability, how long a resource can perform its expected without interruption. There's some use cases for AIOps. These are some metrics tracking systems status in the SRE world. The introduction of new views into the lens of system operations introduced a number of new metrics needed to quantifiably track those attributes. Error budgets. Again, if you go to the SRE course, if you're not familiar with it, error budgets is this idea of knowing that you can't really have 100% reliability or like say availability, but so the difference between what you really expect, what you need to have, and 100% is called the error budget, and that's a budget because it's, you can never get to 100%, but you want to manage according to what your goals are, your service level objectives, which is another metric. And mean time to recover is always important. If you have a problem, you want to make sure you recover before you blow your error budget. Change failure rate is another important metric where you're keeping track of how fast things are changing. So that's a DORA metric, but it is relevant for SREs. So given the complex architecture landscape of cloud native applications, calculating figures goes beyond individual systems, requires efficient integration of data from multiple systems into an application and feature-centric view. So that's the point, that AIOps can help keep track of these things in a complex environment. 40 to 90% of the total cost of the system is incurred after it is released. I don't think this idea it says after birth. Okay, maybe that's a quote from the Google. And the point is that even though there's a lot of effort going into developing something, really a lot of the cost in the over the life cycle of the system, this release is actually incurred from maintaining it, supporting it in operations. Here's the first activity of this module. Again, this is a self-paced course, so I encourage you to do this exercise on your own, or Alec or suggesting to spend 20 minutes on this exercise. So create an error budget for site reliability engineering of your systems. Document 3 ways in which AIOps can help meet the your error budget. Provided an example here. Monthly, so the service level objective could be 99.95% represented by your service responding successfully to requests. Your error budget for failed requests can be accounted for as 4 hours, 22 minutes, and some seconds. It's the 0.05% of a month. Some example use case where AIOps can help, reducing noise alerts when alerts indicated availability problems arise, or accelerated the identification of root cause and therefore reducing time for recovery. Just some examples. So I encourage you to spend about 20 minutes, stop the video, and come up with an error budget and an SLO, error budget for that SLO. Some ways that you think AIOps can help with your SRE.